right, now we're going to go over the activities for 2. We've got Jack and Jill went up the hill. And I want to go over this warm-up because I did see some misconceptions here that I wanted to cover. So it says identify the coefficients and constants in each equation. So for number 1, a coefficient is a number that has a variable in front of it, right? So the coefficient is 64. Our constant is a number without any variables next to it. So our constant is 24. So I've got coefficient is 64, constant is 24. Okay, now we're going to go to number 2. 36 is my constant. And my coefficient is the number with the variable. And this is going to be a negative 8. A negative
and we've got Ralph Wilson.
All right, number 3, I have a coefficient here with a variable, right? So negative 3. And I have another variable, so I have 2 coefficients, negative 3 and 18. There are no constants. No constants here. Number 4, I have 2 coefficients, 42 and 27. But I have a constant of negative 1 right here. So you should have got negative 1 for your constant and 42 and 27 for your coefficients. All right, so getting started, we're going to examine each triangle. So it says for each triangle, write a ratio that represents the relationship between the height and the base of the triangle. All right, so we're going to do a ratio that's 10 over 10, right there. 15 over 4, 15 over 4, 15 over 15. And then this last one is 12 over 3. Then it says to write them as unit rates. So we're just dividing. 10 divided by 10 is 1. 15 divided by 4 is 3.7. 15 divided by 15 is 1. And then I have 12 divided by 3 is 4. How can I use these rates to compare the steepness of the triangles? The higher, the larger that unit rate, the steeper the line is going to be. So up 4 over 1, right? Here, up 1 over 1. That's not going to be as steep. And you can look at these triangles here and you can see that there's a pretty big difference here between, say, figure A and figure B. But when you look at figure A and figure C, they're actually the same steepness. You can't really tell that exactly, but they're the exact same steepness. And so I've got here A and C have the same steepness, and D is the steepest with having a unit rate of 4. All right, 2.1, we have constant proportionality as a rate of change. So on Monday, Jack and Jill walked from their home up a hill to get to the bus stop. They walked 4 yards every 3 seconds. Write an equation to represent the distance D Jack and Jill walked over time T. So distance is equal to 4/3 T. Does this situation represent a proportional relationship? Yes, it is in the form of y equals kx. And then if so, identify the constant proportionality. K is 4/3. Complete the table, then graph the points. So I'm using that information I have from before. It's proportional. We have 0, 0, 0 times 0 distance. Then I have 1 4/3, and we're just multiplying this number times 4/3. So 3 and 4, 6 and 8, 7.5 and 10, and 9 and 12. I've graphed it, and there's our graph. Now, some of these things are going to ask for patty paper. I did not use that. At home, you can use wax paper will work, or something that's really transparent that you can write on. So it says, what is the unit rate? Our unit rate is 4/3. Jack and Jill walk uphill 4/3 a yard per second. All right, number 5. Explain why Tanner's reasoning is incorrect, then explain why the graph goes up as you move from right to left. So Tanner says this graph goes up from left to right because the Jack and Jill were walking up a hill. All right, the graph is not representing the hill height or anything that has to do with that height of that hill or going uphill. The graph represents distance to time. And as we move up in distance, we're going to move up in time too, right? So the longer we go, we're going to keep going further away from home to the bus. All right, so the rate of change. So it says, consider the Jack and Jill situation. Identify the independent and dependent variables. So our independent is time. Time is going to always be independent. Dependent, our distance depends on that time of walking, correct? Our rate of change, 4 yards every 3 seconds, so 4/3 per second. And then considering the rate of change, the constant proportionality, and the unit rate for the situation, what do you notice? They are all the same thing. 4/3 is 4/3 is 4/3. And then how would the rate of change and the graph of the relationship change if Jack and Jill walk faster? So if they're walking faster, they're going to go more yards per minute, right? So they're going to have a steeper graph. And then how would they change if they walked more slowly? It's going to be a smaller slope, or it's not going to be as steep. All right, so I'm going to go through this one because I didn't do all of it, but I wanted to show you a couple things in this slope of a line. The graph shown represents the relationship between the time Jack and Jill walked and the distance they walked from their home. All right, so I've got t equals 1, t equals 3, and t equals 6, and those were marked there for me, those points. Trace the triangle on patty paper. Label the horizontal and vertical sides of the right triangle with their respective lengths. So at t equals 1, right here, I had a unit of 1 and then a unit of 1 and 1/3. So that's the base and the height of my triangle. Then it wants you to do for t at 3 seconds and t at 6 seconds. Again, I did that. So for 3 seconds, I've got a distance of 3. They walked, for 3 seconds, they walked 4 yards. And then for 8 seconds, that was the last one, or 6 seconds, I'm sorry, 6 seconds, they walked 8 yards. And then determine the steepness, and then I just had to divide. 1 and 1/3 divided by 1 is equal to 4/3, which is equal to 8/6. They're all equivalent. And then our triangles are all similar, right? They have the same slope. The next thing I've got here is just general equations. We've got y equals mx. And then how is this equation similar to the equation for the constant proportionality? M is, in a proportional relationship, y over x. So that's not how we always find slope, but in this equation here, it's y over x. All right, I'm going to make another video for the next one.